Hi, this is SHARE C1, a new budget LiDAR scanner, and today I'm going to put it in a real project, 3D scanning for design a bus canopy. It's a government project. Okay, you can see that the starting and the end point is drifting. I think it's drifting on XY plane about 30-40 centimeters. So the SLAM algorithm will fix this when I do the post-processing. Okay, this will be the result for the color point cloud. We have 34 million points, and for the non-color one we have 46 million points, which is about 25% more. Let's analyze the difference between the color and non-color. If you look at I turn both on, color and non-color, and if I turn off the non-color, you see that some part of the building that is very far away will be missing. This is non-color, this is color version. So the non-color will give longer range than the color version. And if you look here, this part of the wall is missing in the color version, and if I turn this on, the non-color version, it just appears out of nowhere. With the non-color one, it's all come out, and the non-color version of the point cloud is clean. You can see this. It's really clean. It shows the intensity of the point cloud, but the color version, it looks just like a photograph to me. This is not a Gaussian splatting. This is just a basic color point cloud. And the camera is only 2.3 megapixels. And you can look at the detail of the color. It's very good. I walked past this point just a few seconds. Some viewer asked me if they can use it for scanning the bus for dimension. I think you can. So you can use it for tracing the body of the bus. If I spend more time focusing on the bus, I mean slowly walking, facing it toward the bus, I think I can get more detail. I didn't go up the front here. The spacing here is too narrow. I just want the dimension of the bus, so I made a quick walk. Let's see, the detail on the wheels, it's all complete. I mean, the fender, the wheels, side mirror. Maybe next time I go back there, I will rescan this with the C1. Some of you also asked me about the range. For the C1, it will use the 40 meters range to build the point cloud. anything above 40, from 40 to 70 meters, it will use that point cloud for tracking only. It has low quality. It will be excluded from the point cloud. And for the best result, it should be somewhere around 5 meters. 5 meters will give you a high resolution for the color. From 5 to 20 is okay. Look at the vending machines here. If you want to focus on something, you can stop and wait for 2 or 4 seconds. Because C1, it takes a photograph every 2 seconds by default. You can increase that frequency, but the default value is 2 seconds. So if you want to focus on the detail of the furniture or something, you need to stop at that location and wait. Let me change to first person. Okay, look at the stair. Let me go back to explore mode. When you have a wider stair, it's more complete. See here, rise and run of the stair is quite complete. The Volkswagen. Yeah, I think I can make a model of this car from the LiDAR scan. Yeah, I think I can. It's faster too because you don't have to put the markers on. And you can scan a car and then you can crop it and save it, and you can put it in the CAD software like AutoCAD or Revit. I like when it can scan the car this clear information. There was a lot of people here. I already turned on the dynamic object removal, but if the people, they are standing still, they're not moving, they will not be removed from the scan. So you can't even see the lighting in there. I didn't walk in here. On the ground floor, which is closer to the scanner, the detail of the object on the wall is very clear. I mean, but if you look on the second floor, it starts to degrade. So you need to be close to the surface. When it's further away, the point cloud will be degraded. When it's closer to the scanner, see here, it's very clear and sharp image. I mean, it's looked very good to me, even though it's not 3D GS, just a simple point cloud. I didn't bring my GPS, so I can't integrate the global position into this point cloud. But if I bring a GPS RTK, I can do that. This small chip here is a GPS pin. Usually in a government building, they will have this. Overall, the point cloud quality is very good. You see, you can read the text, and the text color is very sharp. It looks like photographs. You're going to see the same result in AutoCAD, SketchUp, or Revit. It's just a simple point cloud, not 3D GS. Okay, and most important, my customer, they want the canopy to be extended to this line. So if I use the non-color version, I wouldn't be able to see any lines here, the joint on the road pavement. But if I use the color version, I can see this. Okay, so I'm very happy with the result of the scan. Next, I'm going to bring it to Cloud Compare for alignment, because there is no alignment function here with the SHARE Studio. Okay, Cloud Compare. Good thing about the SHARE C1, you don't have to do a cleaning or anything. You just need to crop and align it before you can use it. So it's quite simple to use. Next, I'm going to align this on the Z axis. I'm going to use the load for the alignment. See here, there's a load joint here. I'm going to use the edge of my monitor to align it. Some people say it's not accurate. No, it's very accurate way you can align this using the edge of your monitor. I can make it 4 microns off the axis. So don't tell me that this is not accurate. It is very accurate way. So after that, I'm going to crop it. I don't need all the area here. So you can crop it using SHARE Studio, but I like to do it here. And then I'm going to save it as LS files and bring it into Recap. Okay, here's in the AutoCAD. This is the point cloud that I import from the recap. Before I can actually use it for modeling the structure, I need to check for the accuracy of the scan. There are several ways to do it. What I usually do is that I will place a checkerboard on the floor, and then I will use the RTK to probe it for the coordinates. Okay, this is a 3D printed checkerboard. I printed with the PTG in a black and white color. So when the LiDAR scanner detects this board, especially for the C1, it can see the contrast of the color, and you can use your mouse to pinpoint and click on the center of the board. Okay, this is a checkerboard that I made. It's highly visible to the LiDAR scanner, especially the SHARE C1. So you can use the checkerboard to recheck the accuracy of the scan. When you turn on the color point cloud, it's highly visible. But if you use the non-color one, it's quite difficult to check. And if you place it more than 3 pieces, you can use it to align the scan data together. For example, if you want to scan a multiple floors building, you can place the checkerboard 3 or 4 pieces on the floor in the overlap area, and you can simply use your mouse to click it, because the distance here on the clicking point is quite small, about 12 millimeters. So when you use your mouse to click on the center of the checkerboard, it will be accurate at some level, less than 1 centimeter. I placed this to checkerboard 1.2 meters away. I recheck it with the measuring tape. So if I check the distance, I can click on here and here. So here 1.205. This scan is considered to be a very accurate scan because you have a known distance for checking it. And in the next video, I'm going to show you how you use this checkerboard for aligning multiple scans together. In this project, I didn't bring the RTK. There's another way that you can check for the accuracy of the scan is by checking the repetitiveness of the column span. Because this building, they are going to make a constant spacing between the columns, or what should we call it, the width of the bay. So one bay is either 5 or 6 meters for a conventional building. So I'm going to measure the repetitiveness of the column bay. This will indicate the accuracy of the scan. So I'm going to click on the point cloud and slice it in the area where this column is. A thin slice, thinner is the better. Click on inside, click on top view. So I can see the column spacing here. 1, 2, 3, 4, about 4 bays. I'm going to create a line. You see this point cloud from C1 is extremely thin. Okay, let me click it here. Okay, let's check the dimension. So it's 4997. Next, I'm going to check the second bay. Okay, the second bay is 5008. Okay, a little less, 4984. Let's check this bay. Okay, 4999. So with the information that I have here, I would say this scan data is somewhere around 10 millimeters of the accuracy error. So I can comfortably use it for designing the structural layout without having to use the RTK or the control point. I was asked by the client to design the bus parking. So if I measure the length of the bus, it's going to be 12 meters. So they want to be able to park 2 buses. So one will be parked here. The second one will be parked here. Okay, I just talked to the client, and this is how they want the bus to be parked. Because they don't want to block the entry of this load, they have to park the bus like this. And it has to extend into the road about 1.2 meters. So there is no other choice. That's how they have to park it. So the blue line will be the boundary line for the canopy that I'm going to make. And for the height, for the lowest point of the canopy, I make it just above the roof of the bus. Okay, here's come to the question, why you need the RTK with the LiDAR scanner. So if you have RTK installed on your LiDAR scanner, when you scan it, each point of the point cloud will have a GPS coordinate. So if I want to find the position of these two columns on the job site, all I have to do is just click on this point and it will show the GPS coordinate, and I can export this into my RTK for staking out the position of the columns. Okay, this is the structure I designed. Okay, this is how I use the LiDAR scan for my work. I don't have to draw the existing building, and I can show this to my customer to see how the new structure will impact the environment. After the approval, I will start to recalculate for the structure and make the shop drawing for the steel frame and the fabrics. Foundation drawings. SHARE C1 is on a Kickstarter for $2,199. I put the link in the description.